Thank you so much, fellow learners. Remember to subscribe. We are saying the following. The following diagram shows the graph of this one. This is the graph. Already they have drawn for us. They have drawn for us. So before you go any further, you should understand the scaling, what is happening. You can see that these smaller boxes, they are 5 from 0 to 5, meaning 1, meaning each small tally, this one small box, it is a 2. So 2, 4, 6, 8 up to 10. So that's what you should understand. You should understand the scaling. Remember to understand the scale which they were using. So we are comfortable on that one. So they have said that, of course, we have seen where it is. They say use the graph to solve the equations. So use the graph. So I should use this graph to solve the equations. So ladies and gentlemen, we'll be looking at number 1, meaning part 1A. Part 1A. They are saying I should use this graph where they say this 27x, mind you, minus x cubed equals to 0. Mind you, now you should understand that what I've been given, the name of this curve, it is 27. This 27 minus x to the power 3. So you should compare what is here, and what is there. Are they the same? If the answer is the same, what is there, what is here is the same as here, meaning it's the name of y. So y is equal to 0. That's what they are saying. So they are just telling me that, Angel, what would be the value of x where y is equal to 0? I know for sure that where y is equal to 0 is along, it is along the x axis. It is along the x what axis. So this is where y is equal to 0. So ladies and gentlemen, please, Mr. Cameraman, follow me. We are saying along this one, this is where y is equal to 0. So we are saying here y is equal to 0 along this one. So I'm just interested in the values of x. What will be the values of x? I know that y will be 0. So there will be x there. If you want, you can say x1, because it is about 3 times x1. We are going to find x1. Again, we are going to find x2. We are going to find x2. We're going to find another x3. So we'll look at this. So we'll start with x1. You can see that for us to see it is along this one, you can see that it is 5. You know, negative numbers, they increase to my left. So this is number 2. So this is like, I'm just saying, okay, the first value of x. The first value of x is, let me write it here. The first value of x is that x is equal to negative 5.2. Negative 5.2, comma, that is the first value of x. So the first value of x is negative 5.2, somewhere there. So you can see that this is how it goes. Next, you come here, it cuts at 0. So the other value of x is equal to 0. So that is the thing. What about the last value of x? You agree with me that it is 5.2, positive 5.2. So these are the values of what? X. I've got 5.2, I've got 0, negative 5.2. So ladies and gentlemen, I hope you are following and you are enjoying. I'm saying, where do we get these values? It is along y equals to 0, along this one. So we just go where it cuts there, y equals to 0. It cuts here, it cuts there. These are the values which are found there. So please, that is what we are saying. We are just saying that the first value was negative 5.2. The other one to be just 0. The other one it will be 5.2. So ladies and gentlemen, these are the values. So I've used the graph to answer that question. This is my A. This is my A. This is my A. My B, they are saying that, Angel, I should find the value. I should find now the value of this one, 27x minus 3 cubed minus 3x cubed equals to 5x plus 10. You agree with me again here, you agree with me that this 27x minus x cubed is equal to 5x plus 10. The whole lot of this, the whole lot of this, you agree with me that the whole lot of this one is equal to 5x plus 10. You agree with me that the whole lot of this is just y. So don't get scared. So it will be just like y is equal to 5x plus 10. So you can see this is a linear equation. So immediately you have this, you should come up with a table. 2 points are enough in respect of x and y. Please, as you are selecting these, table, or should I say selecting these figures or coordinates, go for those which can give you exactly the numbers there that you don't struggle to. For example, when I say x is 0, where there is x here, I put a 0, meaning that I have y is equal to 5 multiplied by 0 plus 10. You agree with me that I have a 0 plus 10. So my y will be a 10. So this is the 10 which is there. So now I can't go for a 1 because it will be 15. Here I can't see 15. I want to have an even number. Let me put 2. So where there is y, I put a twice, okay? Y is equal to 5 multiplied by 2 plus what? 10. You agree with me that it will be 10 plus 10. So the answer will be 20. I can see a 20 there. I can see a 20. Mr. Cameraman, kindly bring your camera here. You will find that I have a situation like that. I've got the first point, which is the first point is that, remember the first point we got on this one. On this, the coordinates is 0, 10, and I've got another point which is 2, 20. So these things I can do them. So 0, 10, I believe it is here. It is there. You agree with me that it is there. What about 2, 20? 2, 20, you agree with me it is somewhere here. This is 10, 20, so it is 2, 20, it is somewhere there. So these 2 points, I can use a ruler. So ladies and gentlemen, you should go with a 30 centimeter rule in the exam room because you don't know what you will find there. So I'm going to join these points using my ruler. I will do this, my rule. Of course, we are used to call it a ruler, but I will use a rule. There we go. I'm ruling. I'm going to rule. You can see this is a point, this is a point. And be firm, be firm, be firm. You draw a straight line. You can see how I've drawn. So I've drawn that line. Where are those points coming from? And so these points which we got, these points, where did we get these points? I said we got these points after we drew a table where we said this x, you are in an exam, this is y, 2 points are enough. I said if it is this is 0, I'm replacing it here. Mind you, I'm getting now whereby I want to come up with this one where y is equal to 5x plus 10. I'm saying, I've already explained, I said if you replace a 0 there, here we have a 10. When you put a 2 there, 2 times 5, 10, plus this 10 equals to 20. So these are the points I came up with. So the first point is 0, 10. So the first point is 0, 10, which is here. The other point, it is 2, 20. So it is 2, 20. 20 is here. So this is the 2. So this is the line. I had to join this with a straight line. Now, where do I get the values for x? Where are the x's? It is where this line which I've drawn the equation, which I'm going to name it. You have to name it. Y is equal to 5x plus 10. That is the name of the equation, that straight line. So now where it joins or it cuts the graph, somewhere there. Mind you, there is at least some allowances or range of the answers. It won't be exactly. So meaning that it is where we get, you can see it cuts somewhere there. So I should go back, I should go up and find the answer, which is here. So this is where I find the answer. Again, where does it cut this graph? It cuts it here. It cuts it here. You agree with me that here it is here. It cuts it here. I should come down. Should come down here. So I should pick this answer there. And where else does it cut the graph? It cuts the graph somewhere there. Ladies and gentlemen, you have to be neat and smart. It cuts the graph somewhere there. You agree with me that it is somewhere there. So again here, you can see our pen is disappointing us. Whatever the case, what it is, we are going to use, let me check if I have another pen so that I can demonstrate nicely. So ladies and gentlemen, we continue. We are saying that where this graph, it cuts here, you bring down with your ruler. You bring down with your ruler. It shows there. So you can see that these are the 3 points. I've got this one. Mr. Cameraman, let's hope your camera is able to catch this one. You have got this one. I've got that one. I've got that one. So now from there now we are able to see, but remind you, we are coming from this direction. We're going to the left. So this is negative 4.2468. So somewhere there, 2, 4, 6, 8. So this is the first value for x. So we are saying the first value for x will come there now. You have to explain how you are getting that x. We are saying the first value of x, this is a. Now we are looking at b, just on the graph. On the b, we are saying the first value of x is negative 4.8. That is another value. The other value of x, you can see that it is from 0. So it is 2, 4. Remember, it is 2, 0 point, that is 0.4. You have to be very careful. You have to understand, so it will be 0.4 because it means each one of this is 0.2, 0.4. So you remember what we discussed. Here it will be 4.4. You can say 4.2, 4.4. So the other one, it will be x is equal to, be careful, this is 4.4. So these are possible values of x. These are the possible values of x. I've said negative 4.8, comma, x is equal to 0.4. Again, one is x is equal to 4.4. So these are the possible values of x. So here you have to show, you know, where the x are. We are saying the other one, the first one, it will be negative 4.8, sorry. Again, another x is equal to 0.4. The last but not the least, you will agree with me that it will be x is equal to 4.4. So these are the possible values. Somebody is going to ask me, sir, are they exact? No, sometimes we give you an allowance, plus or minus 0.1, plus or minus 0.1. So if someone will get 0.5, 0 point somewhere there, it's fine. We are going to give that range. Ladies and gentlemen, I hope you have enjoyed how we have gotten these values. So whereby you are given the what? You are given the graph already, and then you have just to, like this, it means they really assisted you, because there's no need of you making a graph or drawing the graph. So already the graph has been done for you, just have to interpret it. We go to part 2. So part 2 will continue. Thank you so much. Welcome back. We are on part 2, where they say calculate an estimate of the gradient of the curve at the point where x is equal to 2. So kindly, here x is equal to 2. So in an event that you don't want to waste much of your time, you come here, just say, okay, this is x is equal to 2 is somewhere there. You can see 2 is here. So you come there. So it is somewhere there. You agree with me that this is exactly because each box is about 2. So 42, 44, of course 46. So the first point, you are going to bear with me that the first coordinate for this one, since you have to take these points. This point is a very, very important point. Don't ignore it. The first point you are given, where they have directed you at, you should find a gradient where this x is equal to 2. Where x is equal to 2, y is equal to 46. So it is a gradient. So sorry, it's a coordinate 2, 46. It's like this. And I'll call this x1 and I'll call this as my y1. This is how we get these, coordinates. Now what you should do is you get your ruler. Mind you, what is a tangent? I should draw a tangent. A tangent is a straight line which touches the curve at one point on. So I come like this. So you agree with me that when I put my ruler nicely, I can see that I can see the point which I had drawn here. I can see the point which is here. But again, I can see something. What is that which I'm able to see? I can see it passes through the 20. So this is the tangent. So this is the tangent. You agree with me that this is a tangent. Since this is a tangent, it passed through. Of course, I can call it 0, 0,20. 0, 0,20. So it passed through. Apart from passing through 2,46, again it passes through this part, which is another one. I'm saying another point which I can see is that it will be 0, 0,20 like this. So this is x2, y2. So they are talking about gradient. Then I go back to the ordinary, our traditional, now to find the gradient. You agree with me that it goes like this, and then it goes like this, it goes like this. Then you substitute gradient. What is my y2? My y2 is 20. Should subtract my, remember this one, subtract this one, my y1 46 over, you agree with me that this is a 0 minus a 2, and you agree with me that when you do the needful, we do the needful here, I'll get negative 26 on top, and then down there I'll get negative 2. Whereby negative and negative is positive, I will remain with the positive. Then when you do the correct way, you find your gradient is 13. So ladies and gentlemen, here I'll find my gradient 13. If my gradient 13, mind you, we are doing part 3. We are doing part 3 of this question, mind you, which came in 2022. So from there, I said the first thing is give respect to what they have given you. So the point they have given you is where x is equal to 2. I had to find the value for y. My value for y, ladies and gentlemen, is 46. So that is the value of of y. And then if you do the needful following this method, you agree with me that I substituted, I came up with 13. So my gradient is 13. It means I've gotten that 2. So that's the thing. Then the other part, now they are saying angel, you should find the, we should find the area. We should find the area. It is an estimate. Be careful. It is an estimate. I want us to see how this area will come about. You see, they are talking about along. So Mr. Cameraman here, for the sake of learners and the followers to see what I'm talking about, I'll use a blue pen instead of red. They are saying along this line, where along the x-axis, and this one 3. So it cuts the 3 somewhere there. So they're talking about this area, which I'm going to explain. Thank you. Along the, we are saying x is equal to 3. It is somewhere here, ladies and gentlemen. I'll use my blue pen. So this is where x is equal to x. This x is equal to 3. And they are talking about this area. So this is the area they are talking about. This is the area they are talking about. So we are going to estimate. It's not about using, calculus integration to find the area. No, you have to find out this area. So ladies and gentlemen, first of all, you have to establish this this rectangle 2 by 2. What is their area? If you see from 0 to 2, so here in this case it is 2, and there from here to there it is 20, so it is 2 times 20. So what I'm saying is, for the sake of learning, we'll come back to this. Want us to know something for those people who are following me. We are saying the box I was talking about is this one. This is a bigger box which I tried to imitate. So now we are going to know that each bigger box, like this one, this is a 2 by 2. Here we are saying it is 2 centimeters, and according to the scale we are given, this is 20 centimeters. So they are saying, Angel, we should find the area. How do we find the area? You agree with me that area is equal to this 2 should multiply by 20. This 2 multiplied by 20, you will get a 40, centimeter squared. 40 centimeters squared. So that is the area of that box which is on that part. So now what you should understand, there are 100 smaller boxes. So meaning this small box here, what is the area of this one? What is the area of this one? So this smaller box now, because they are 100, maybe if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 100, meaning 10 times 10, that is 100. So when you divide this by 100, you get 0.4. 0.4 centimeters squared, meaning this one, each box, it is 0.4 here. Each box is 0.4. That's what it means. So for the estimate, the easiest, we'll see how many boxes are there. If you want, you can count, but looking at it, if you don't mind, you can count them. And thereafter, we can find the area automatically. We'll see. Mr. Cameraman will come back now. I hope you have gotten the concept there. So now what we'll do is we'll try by means to say, okay, what it is we can count these smaller boxes. We can count them. So in this case, for us not to waste time, look what I'm going to do. I will say, okay, here from here, there are 1, 2, 3, 4, 5. Then we go upwards. You'll see what I will do. So here, I know that here there are 10, another 10, that is 20. So already, if I take this one, this is 100. Already the 100. This is 100. So 100, if I go, already 100 is there, so we come with 1, 2, this is 1, 2, 3,
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the other boxes are 20. You also come here and count all the boxes, starting using this diagram that you have been given. Count this part. Try to count this part. So you also count this part. Yes, this part you also count it. So let's count this part. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So after getting that 28, this is what you do. If you want, you can do it on your graph paper, but me, I just want to do it on my board. From there, you can go and that one reduces the total of all the boxes. You multiply it with 0.4, which is the area for each box. Then the number that you get, the number that you'll get, 80 centimeters squared. Then from there, this 80 centimeters squared, you get it again. Oh no, you get 0.4 times 2080, which is equal to all those boxes that we counted at first. Then from there, you do the needful, you do the calculations. Then what you get is 11.2.
You are going to get 11.2. Then I'm going to add, this is area 2. So total area, we are going to say area, we are just adding 80 plus 11.2. You agree with me that this is 91.2 centimeter squared. So this is how we do it. So please, ladies and gentlemen, you have to establish to say a bigger box like the one I was demonstrating there. What is it? What is its area? The area is whereby I know the bigger box, meaning for those who people who are not understanding me properly, I'm saying if I want, I can say, okay, from there to there, another one. So this is a one box already. So I can see this part, okay, I can see the top part and this box. So this area, if you look at this area, it looks somehow like this area. So if I put it here, becomes two boxes. So what I'm remaining with here, this is the 28 where it is coming from, because I've taken this part, I put it here to become the whole box, so that there are two boxes. So ladies and gentlemen, I hope you are following what I'm saying. So this is how we estimate the area. Don't use the YDX. Thank you so much. I hope you had a nice time. And I said you should establish what is smaller box means. You had a nice time with our lesson. Today we are looking at the cubic function. Thank you so much. God bless you. I love you.